You see this orange mess in my hands, Alex? This was supposed to be a precision engineered bracket for my shop vac. Now it looks like a neon tumbleweed that gave up on life. I walked out to the garage this morning expecting a finished part, and instead, it looked like the printer had a mild cerebellar stroke at 3 in the morning.
I told you that overhang was ambitious, Tiger. You're a master with a chisel, but I think you forgot that plastic doesn't abide by the same rules as oak. Gravity is a cruel mistress when your wood is actually molten goo being squirted through a tiny needle.
It's the ego, honestly. You spend 20 years convincing a piece of hickory to stay flat, and you think you can just tell a 3D printer what to do. But designing for FDM, that's fused deposition modeling for the folks at home, is a whole different brand of chess. You aren't just making a shape, you're choreographing a structural dance where every layer depends on the one below it being exactly where it promised to be.
Which leads us to our deep dive today. We're talking about design for additive manufacturing because, as Tiger just demonstrated, you can't just take a file meant for a CNC mill or a lathe and expect the printer to figure it out. So, Tiger, before you try to melt that orange hairball back into a spool, where did it actually go wrong?
It's the air gap problem. These machines are amazing, but they haven't figured out how to print on thin air yet. I had a bridge in the middle of this part, basically a horizontal stretch between two islands that was about 20 millimeters long. Without support, the first layer of that bridge just gave up. It sagged like a wet noodle.
Is that the technical term, wet noodling?
Close enough. If you're bridging more than 5 millimeters, you're basically gambling with physics. You might get lucky, but usually you get these dangling loops of filament that look like a bad haircut. The pros will tell you to either shorten the bridge or bit the bullet and use support material. But man, I hate supports. It's like wrapping a gift in duct tape. It's a nightmare to get off, and it leaves these little scars all over the surface.
I've seen your support removal technique, Tiger. It usually involves a wood chisel and a lot of swearing. But if people want a clean finish without the scarring, they've got to rethink the geometry, right?
Exactly. One of the handiest tricks is the split and glue. Instead of trying to print a complex, spindly chandelier in one go, you slice that sucker in half, orient both halves so the flat side is on the bed, you get a better surface finish, no supports, and then you just use some CA glue to marry them together. It feels like cheating if you're a purist, but in the shop, a finished part in 2 pieces is infinitely better than a perfect one-piece failure.
Okay, but what about the stuff you can't just glue, like holes? I saw you trying to shove a bolt through a printed hole the other day, and you were turning purple.
Don't remind me. That's the vertical hole shrinkage trap. See, when that nozzle zips around in a circle to make a hole, it's squishing the plastic down to make it stick to the layer below. That squishing force flattens the bead of plastic, making it wider, and when the bead gets wider on the inside of a circle, the hole gets smaller.
So the slicer says it's a 5 millimeter hole, but the reality is more like a 4.8 millimeter maybe if you push hard enough.
Spot on. And it's worse on small holes because the ratio of nozzle size to the hole diameter is higher. If I need a hole to be precise, I mean really precise, I don't even try to print it to size anymore. I'll print it slightly undersized on purpose and then run a drill bit through it. It's the marriage of high-tech and old-school reliable.
That feels like a very Tiger solution. I'll use the $500 machine to get close. Then I'll hit it with the $10 tool to make it right. But let's talk about the orientations. You mentioned fillets versus chamfers. I know you love your rounded edges on furniture, but I heard they're a disaster for the bottom of 3D prints.
Oh, they'll break your heart. If you put a fillet, a rounded edge, right on the print bed, the very first few layers are trying to print at an almost horizontal angle. It's the steepest overhang possible. You end up with a messy, raw edge that looks like it was chewed on by a disgruntled squirrel. If you want that pro look, you go with a chamfer. A nice 45-degree flat angle. The printer loves a 45-degree angle. It can climb that like a mountain goat because each layer has plenty of the previous layer to sit on.
It's those little hidden rules of the road that trip up the beginners, like wall thickness. I've seen people design things with walls so thin they don't even show up in the slicer. It's like trying to build a house out of tissue paper.
That's the perimeter secret. Your nozzle is usually 0.4 millimeters wide. If you design a wall that's 0.5 millimeters, the printer looks at it and goes, I can't do that, chief. It's either one wall or two. There's no such thing as a wall and a half. You've got to design in multiples of your extrusion width. If you don't, the slicer might just leave a gap, and you end up with a part that has the structural integrity of a cracker.
Speaking of structural integrity, I saw a video from the folks at Slant 3D talking about how to actually connect these parts. Because let's be honest, wood glue doesn't work on PLA, and sometimes you don't want to rely on just CA glue. They use things like pins, fins, and snaps.
I love a good snap fit, but you have to remember that 3D prints are like wood in one very specific way. They have a grain.
Wait, plastic has grain?
In a way, yeah, the layers are your grain. Like if you print a long, thin pin standing straight up like a flagpole, it's going to snap along those layer lines if you look at it funny. It's the weakest point of the part. If you need a strong pin, you print it lying flat on its side so the grain runs the length of the pin.
Okay, let's pause. Let's talk tolerances. If I'm designing a drawer to slide into a case, in woodworking, I might leave a 1/16 of an inch. What's the magic number for 3D printing two parts that need to fit together?
Life is a game of millimeters here. If you want a tight fit, like something you have to tap in with a mallet, you're looking at a 0.1 millimeter gap all the way around. If you want it to slide comfortably like a bolt in a hole, go for 0.2 millimeters. If you go 0.3, you're starting to get into rattle territory. It sounds tiny, but in the world of plastic extrusion, 0.1 millimeters is the difference between a functional tool and a piece of scrap.
And this is where the iteration part of making stuff is actually fun. Back in the day, if you messed up a mortise and tenon joint, you were starting over with a new piece of lumber. Here, you just change a number in the CAD, hit print, and go have a sandwich.
It's true. It takes the fear out of the mistake, but it can also make you lazy. You see people printing the same failed part 6 times, changing nothing, hoping the printer gods will be in a better mood. I've been there. Watching the same failure happen in slow motion is its own kind of shop penance.
I've seen you staring at that printer bed like you're trying to hypnotize the plastic into sticking. Stay, don't warp.
That's the other beast, warping, especially with materials like ABS. You're printing hot, and as the plastic cools, it shrinks. If the corners of your part cool too fast, they'll peel right off the bed like a stale grilled cheese sandwich. You've got to manage that heat. Sometimes that means a heated bed, sometimes it means an enclosure to keep the drafts out.
Or just sticking to PLA until you know what you're doing.
PLA is the grandpa's pine of the 3D printing world. It's forgiving, it smells a bit like maple syrup when it melts, and it stays where you put it. But even with PLA, if you don't respect the geometry, it'll bite you.
Now that looks like something that didn't come from a tumbleweed factory. What did you do differently on this one?
Perspective. I stopped trying to make it look like a wooden part. I leaned into the strengths. I used the honeycomb infill for the internals so it's light but incredibly rigid. I used those 45-degree chamfers we talked about so the edges are crisp. And I designed it to be printed without a single gram of support material.
It looks professional, almost like it shouldn't have come out of your shop.
Hey now, sharp tongue for someone who still hasn't finished that birdhouse.
Touché. But honestly, the takeaway here for the makers listening is that 3D printing isn't just a send to printer button. It's a language. You have to learn how to speak layer height and overhang angle.
Exactly. Don't fight physics, work with it. Understand that your part is being built from the ground up, one hair-thin layer at a time. If you give those layers a solid place to stand, they'll build you anything you can dream up. If you don't, well, you'll end up with a collection of orange tumbleweeds like I have.
So, final word for the folks at home?
Stop trying to print the impossible. Slice your complex parts into simpler ones, trust your chamfers over your fillets, and for heaven's sake, give your holes an extra 0.2 millimeters of breathing room. The machine isn't your enemy. It's just a very literal-minded apprentice.
And maybe watch the first 10 layers before you go to bed.
Oh, absolutely. If it's going to fail, it's going to do it while you're brushing your teeth.
Thanks for joining us in the Tiger Den. Go make something, and try to keep the plastic on the bed, not the floor.
See you in the shop.